this week we're going to be talking about balancing chemical equations, which I know some of you have been asking me about for months, so I hope that you're happy that we're going to finally be doing that. So we're going to write down a few slides so that we have a basic understanding of what we need to know before we balance equations, and then we'll do most of our practice in class. So the first thing we need to know is, what is a chemical equation? So it describes a chemical change. So for example, when we were talking about flammability, or when we were talking about rusting, baking soda and vinegar together, all of those are chemical equations. All right, so there are a few parts of an equation that we need to know. The substances that go into the reaction that are normally on the left, but not always, are the reactants, because they react. The substances on the right-hand side of the arrow most of the time, but they are also what is formed in the reaction, are the products. And then the way that we show that a reaction has happened is by drawing an arrow. Okay? So one more time, just so you kind of have the definitions in front of you. The reactants are the chemicals you start with before the reaction. So if we were making lemonade, our reactants would be water and lemon juice and sugar, okay, or the powder if you use powder. And then the product is the new chemical or chemicals formed by the reaction. So the product would be lemonade. If we were making spaghetti, our reactants would be sauce and noodles and meatballs. And then the product is spaghetti. So your middle school teachers may have taught you that the reactants are always on the left side and the products are always on the right side, but that's really not always true, because when you get up to higher level chemistry, sometimes you have reactions that go the other way. They're called reversible reactions. And so in that case, your reactants would be on the right side and your products would be on the left side. So I don't want you to learn that. I want you to learn that reactants is what you start the reaction with, and the products are what you finish the reaction with. All right, two more things that are really important are subscripts and coefficients. Subscripts show how many atoms of an element are in a molecule. So for instance, H2O, there are 2 hydrogens and 1 oxygen. So we don't have to write the 1, but we do have to write the 2 so that we know that there are 2 hydrogen atoms in that molecule. A coefficient, on the other hand, shows how many molecules there are of a particular chemical. So if I have 3 H2O, that means that there are 3 water molecules. So I could separate them. 1 H2O, 2 H2O, and 3 H2O. All right, whereas a subscript just means there are 2 hydrogens in the water molecule. Okay, so we're going to be going over that again in class on Monday. So if that's a little confusing to you, just try to think about it and just kind of let it sit in your mind. And that way, on Monday, when we start drawing it out and stuff like that, it might make more sense to you. All right, so here's a pretty popular chemical reaction, is when hydrogen and oxygen join together and they make water, just like you're seeing in the picture right here, hopefully. So actually you have to have 2 molecules of hydrogen and 1 molecule of oxygen, and it forms 2 molecules of water. So like you're seeing, the little green dots are the hydrogens and the red ones are the oxygens. And so you have 2 of the hydrogen molecules, 1 molecule of oxygen, and when they join together, they break apart into 2 different water molecules. So just FYI. All right, now there's a really important law that is involved here, and it's called the law of conservation of mass. And it basically means that matter is neither created nor destroyed. So we can't make anything new, and we can't take anything out of the world altogether. So for example, you might say, sure, I can burn some wood and then it won't be here anymore. Well, that is true. It will not be wood anymore, but it will be ashes and there will be some stuff in the air, in the smoke. So, really, you may have taken a piece of wood off of the earth, but those atoms and molecules and what the wood was made of are still on the earth somewhere in some form. Okay, just like perfume, it's liquidy in the bottle, and when you spray it, it goes into the air, and you can smell it, but once you can't smell it anymore, it doesn't mean it's just disappeared. It just means that it has floated far enough away that you can't smell it anymore. But it's still out there somewhere, which is why they say it's bad for your cars to let out a lot of smoke. And it's bad to use a lot of hair products that put chemicals into the air. It's because it never really goes away. It's always in the atmosphere somewhere. Okay, so when we're talking about a chemical reaction, we mean that the number and type of atoms going into a reaction must be the same as the number and type of atoms coming out. So if we have 2 hydrogens going into a reaction, then we're going to have 2 hydrogens at the end as well. All right, and we're going to see an example of that. So basically, if an equation obeys the law of conservation, it's balanced. No questions asked. If it's not balanced, then it is not obeying the law of conservation, and so we know that that equation cannot be correct, and we're going to have to change it so that it is correct. Okay, so here's an unbalanced equation. CH4 plus O2 yields CO2 plus H2O. So if we were to draw out, and we will do this week, if we were to draw out what was on the reactant side, we have CH4 is that gray and green molecule. So we have 1 C and 4 H's, right? 1 carbon, 4 hydrogen. And then the O2 is 2 oxygens put together. And those are the red one. On the product side, we have CO2. That's the red and gray. So this carbon is gray, just like it is on the other side. And there are 2 oxygens connected to it. And then H2O, there is a red oxygen with 2 hydrogens on it. Now, it might look great to you right now, but if we count up everything, we know we don't have the same amount of stuff on each side. So we have 1 carbon on both sides, so that's good. But on one side, we have 4 hydrogens. On the other side, we have 2 hydrogens. And then on the left side, we have 2 oxygens, and on the right side, we have 3 oxygens. So we have to figure out what happened to some of our oxygens and hydrogens in this reaction. So if we were going to balance it, we would know that we actually need 2 oxygen molecules starting off, and we're going to get 2 water molecules at the end. So now if we look at it, we have 1 carbon on each side, and we have 4 hydrogens on each side and 4 oxygens. All right, so I don't want you to really worry about how we did this if you are not sure how to balance an equation, but I just want you to notice that what we changed was the coefficients. So we added a 2 in front of oxygen on the left, and we added a 2 in front of water on the right, and that made it equal out on each side. So we can do that. We can change how many molecules we have. What we can't change is the subscripts. We cannot change how many molecules are in an atom, because that just depends on how they bond, and we have nothing to do with that. They bond the way that we've been talking about for the last few weeks. So here are some final things to note. All right, remember, matter cannot be created or destroyed. So we can't make something in a reaction that we didn't start out with. We can combine things differently so that we have a different looking product, but we are only using atoms and elements that were there in the beginning. The second thing is that subscripts can't be added, removed, or changed. You can't change H2O into H3O. You can't do that. Now, maybe that will happen in the reaction, but if it's not balanced, you can't change a subscript to make it balanced. You can only change coefficients. All right, that's my third point. You can only change coefficients. Number 4, coefficients always go in front of chemical formulas, never in the middle. So if you have NaCl and you really only need to change the Cl, well, guess what? You're going to have to change the Na too, because you have to put the 2 in front of all of it. You can't just choose what you want to pick and choose and put it in the middle and all that stuff. All right, some last minute tips. Try balancing the big formulas first. Save the little things for last. So if you have 2 NaCl plus O equals whatever, balance the NaCl first and then save the O for last, because it's just one element. So it's probably going to be a lot easier to balance by itself. The second thing is, if the same polyatomic ion appears on both sides of the equation, it's usually okay to treat it as one unit. So let's say we have SO4 on the left and on the right we have SO4. That probably means that the S and the O go together and that they didn't change. So we can treat that as one. We don't have to treat it as an S separately and an O4 separately. Okay, we're going to talk about that more in class. Thirdly, there's no particular way to balance equations. We're going to teach you a couple of ways, but you may also know a couple of ways that are different. But the ultimate thing is that you just keep your mind open to all the different ways, because you may look at the way we teach you and you might say, I know a faster way and it's better and I learned it in middle school and I'm going to use it, and it might work most of the time for you. But don't forget that you're going to get some really hard equations. And so we're going to teach you some ways that we know to solve the hard ones. And then, you might want to be a little creative and maybe use your way a couple of times and our way a couple of times. So it's important to listen, even if you think you already know how to do it, in case you might need another idea one of these days. All right, that is all I have for today, so I will see you guys later. This is due Monday, and come to class ready to do a little bit of math and a little bit of creative thinking, because science and chemistry is a little math, but it's mostly just understanding how things rearrange and become new things. So I hope you enjoy it, and I'll see you later.